Right, so what were we doing? We had just gotten header parsing working. Next is we gotta finish chunks. So Lua chunks have the list of instructions, constants, and function prototypes. And function prototypes are the same as a Lua chunk, except they never have the source name defined. We need to parse the instruction list. To parse the instruction list, we need to read in the integer that gives us the size of the instruction list. I think it's just the length of the list, not in bytes, but in number of instructions. So we'll say let size code is buffer next byte. Oh wait, no, it's not next byte. It's next integer of size header size int. This is a little clunky having to do all of this over and over again, so maybe we'll figure out some way to do that later. That's a little more clean. And then we just parse the instructions out, which is just reading a whole bunch of integers, because it's byte code, so the instructions are they're all like 32 bits. I think it's interesting that we define instruction size, because that like doesn't ever change. But we'll adhere to the spec and we'll do it like this anyway. So we'll go from this to header, or no, to size code. Of course. And we will read in instruction. A raw instruction, let's call it. Next integer of size. We'll give it header. What did I call it? Okay, so this is a little stupid that I did it like size int size t, and then I switched it around for these. So maybe let's get ahead of the curve and switch it so that they're consistent. Yeah, that's better. Right, as you size. Maybe I should just cast these like when I first do the parsing here. Yeah, why don't we do that? Size int will call you size. Same with these. So I don't have to do this cast every single time. Except when we're down here. And this is now size instruction. And this is now, oops, come on. Size Lua number. Okay, I think we're fixed. Yeah. Okay, so we have read in an instruction, and we don't have to do anything with it right now. I really just want to make sure that we're reading in the whole file and doing something with every part of it. So that means at least getting the instruction list, the constant list, and the prototype list. We can ignore for now the source line position list and the local list, because those are just sort of metadata. So we'll do let size constant is buffer, exactly like size code. So let's just copy that. And this is, yeah, size int. And a constant is a little harder to parse. It's like for const index and 0 to size. Constants will get the type of the constant, which is just a byte, I think. Yeah. And then, depending on the constant type, we have to do different things because there's different types of constants. So let's make a new enum. That is, let's put it here. It can be either nil. Not sure why it aggressively auto-completed there. Boolean, which can have, we'll just do this. And then number. For now, can we just do that? What's the Jakt word for a float? F32 or something? And then we have strings, so capital S. Why would I want to stream? So we have a Lua constant. So if it's type 0, we'll do let constant Lua constant equals this, and here we'll have nil. Do I have to add the yeah, it wants the namespace. If it's 1, we have a Boolean. And we have to give it buffer next byte. It's true if the next byte does not equal parameter labels. Yeah, that works. Okay, that's pretty easy. If we have 3, then it's a Lua number. So Lua constant number. And I don't have a function for parsing that yet. 4 is a string, so how about we write some code that... Oh wait, we have load Lua string for this, so we'll do value load Lua string, give it the buffer. What else does it want? Header. This is number. And to load in a floating point number, what's the best way to do this? We want to load in 4 bytes and sort of reinterpret them as a float. Oh yeah, okay, you're right. Sorry, I haven't been like checking chat. I have the reference document open on my other screen instead of just the chat. So let's not call this string. Let's call it L string. Yeah, sure. And now I need to figure out how to load a floating point number in. Oh, come on. My typing skills are better than this. So for now, Let's say to implement more Lua number types. But since I downloaded Lua 32-bit, I should only get single precision floating point. Byte 1 is buffer next byte, and then we'll let's try it. Byte, let's put this on parens. Byte 1 or byte 2 left shifted by 8. 3, 4, shifted by 16 and 24. Oops. Can we do that typecast? Maybe we should put a test in here. Test num is 3.14. Yeah. And then down here we will return constant number. Do I need throws here? I don't know. I guess not. And then in here, maybe I can just say load Lua number. A little weird, but that's okay. And I should probably do a little bit of a print, like yeah, like that. We'll do const index is type blank constant. Can I do that? I think I can. So we'll do another print line just for debugging. Say we have blank constants. And we can do the same for the instructions. Cool. Very cool. So we don't save these anywhere, but we parse them, which means we can do testing. So let's Lua C 5.1 test.lua. Oh, I moved it. Did I put it there? I think I did. Looks like that cast I tried to get away with earlier is not gonna work. Anyway, yeah, I filed an issue for this this path issue. Maybe I need like I need like an unsafe C++ so I can just reinterpret this as a float. Maybe I can do like a union or something. Maybe that's what I do. Let's try it. Is it CPP? And we can say final number oh, good point. The shift isn't even going to work. I need to like expand them out. Well, let's do like a union. I gotta be honest, I really don't like know how this works. I have to put it in quotes. VS Code does not like that. U32. Thank you. I should probably do like multi-line editing or something. Oops, that's not how you do that. Also not how you do that. How does this work? There we go. And then we can just delete the, there, yeah. Left 8, left 16, left 24. How do unions work? I have to actually look this up. I've like never done a union in C++ before. I don't even know if this is the right way to do it. Do a little bit of Googling. Just a little bit. So yeah, we got to give it a name. Float converter. Oh, it's like a type name. So float converter. What type does Jakt use internally for these numbers? Is it like one of the C++ built-in types? We'll just look it up. Like an unsigned int, I guess. Like that. Semicolon. And then we want a float as F32. I hope that's how you're supposed to do it. And then we can make a float converter with a new value of our byte shifted or bit shifted bytes. So we'll do like byte 1, byte 2, byte 3, byte 4. Final number is, let's start this out as like a empty struct or something. We'll do that. This is FC, and then final number. Sorry, this is like really scrambling my brain trying to work in two languages at once. Final number is FC dot has F32. Don't forget the semicolon. Well, we should compile this and see if it works, right? Oh, right. Well, it compiled, which is a good sign. That means I didn't make some egregious syntax error in my unsafe C++ crap up here. Oh, let's run it. Hey, that's interesting. Understood this, but this is wrong. This is very wrong. Maybe I should print out the size. We're like reading in the wrong number of bytes or something, because we're only ever reading in 4 bytes. Maybe I should print out what the size of a Lua number is when I'm parsing the header. Yeah, let's try that. 8. Why is it 8? That's it, isn't it? Oh, right. Well, it's 8 by default, but it's weird that it's 8 if I have a 32-bit version of Lua. Okay, well, we'll just have to rewrite this a little bit. 24, 32, 40, 48, 56. So the type that we want here is like an unsigned long int or something. Yeah, because that guarantees that it's a 64 bits. This will say double. This is one thing I've always found weird about C++ is these like insane types. This is so weird. I don't know why we thought this was normal. Being explicit about it is much better than having to look up what certain types mean on your machine. And we'll more the rest of these. Okay, let's see. I'll check chat. Nothing. This is weird. Shift count. Oh, right. No. This makes complete sense. We want U64 here. I don't know why I have so much trouble with these multi-line editing controls. Hey, that was so easy. Look at that. We've got all our constants. So yeah, the reason we have a constant called print is because print is a global function, And in Lua, when you call a global function, you call it by name using a string, which is a little weird. I think the Lua virtual machine, the original, is written in C. And it just like goes and looks up the function in a dictionary. That's the global scope. So we can see we have 9 instructions, and that has to be correct because we're parsing the constant list correctly. So we read in the right number of instructions and we have the length right. So that's good. That's good enough for me. So what do we do next? Should we try parsing some instructions, or should we finish parsing the file? If you have any input, trying the float parse in Jakt, you think it will work now? Yeah, I can try. How does multi-line commenting work in Jakt? Do I just... Here. Let's just do it the boring way. Here we go. Lots of // apparently. It's good to know I was on the right track. I don't think it really likes it. I'm okay with doing this sort of janky, unsafe block. It's fine by me. No, there's no reinterpret cast going on here. We'll just ignore that. It's fine. Right, so what was it? I was deciding whether we should keep parsing the file or start taking apart the instructions and looking at opcodes and things. Maybe it's best to start with just parsing the file, because we have to do up values, and it just makes sense to do things in order sometimes. So once we start doing opcodes, we're doing real VM stuff, and right now we're just doing binary stuff. And I'd like to stay in the binary realm, which means next up we have to parse out function prototypes. This one's a little weird because this is recursive. So we'll have size prototypes is same as this. Do println. We have function protos. Zero to size prototypes. Sorry. Prototype. Load Lua chunk. And this is the advantage to using a buffer as like making a class that reads a buffer instead of passing a U8, a byte array. It's just so much cleaner. So once we have the prototype, again, I think I'll just discard it for now. We just want to do this so that we advance the right number of bytes. Size line info. Oh, local. What am I doing? Am I writing Lua right now? Maybe I should duplicate this for the other 2 lists as well. We'll just get in the habit of logging everything. These are also just integers. Line number. Actually, the index corresponds to instruction positions, so we'll just say instruction position. And then line number is the line number where that instruction was generated from. Buffer. One of these. And that parses that. And then our local list is a string and 2 integers. Size locals, and we'll read in a string for the name. Or it's not buffer, it's like a load Lua string. And then start of the scope and the end of the scope. Two more of these. These are also line numbers. And then last is up values, which is just a list of strings. So for local, or no, for up values, index in 0 to size up values, just load in the names. This is just like debugging information, really. So I don't think any of this is really necessary to run. Yeah, so that looks, well, I'm not sure about this. No, so we do have a name here, so we're doing something wrong. I'm probably doing something really stupid, actually. Oh, I forgot to change the debugging message. So that we're probably correct. Simple copy-paste error. So yes, we do have 9 line positions and 1 local variable. So maybe we can print out the local variable name and just verify that we're reading that correctly. So we'll say print line local variable blank is called blank. We'll say locals index local name. Yeah, look at that. Okay, so we're parsing this file. We're like there. With this code, we can parse an entire little byte code file. Except for we need to parse the opcodes. So we should probably start out with creating like an instruction class. You know what, actually, we haven't done? Lua chunks need to actually store these things. So for now, we'll just make this like a U32. Public, what is this, constant list? Array of Lua constant. Can we do that? Can we recursively store more objects of the same type? This should be, we should have a class for this. Once again, using use sizes because that's what I did, and now I'm stuck with it. That should do it, actually. And now we can store all this good stuff in a Lua chunk. So we have, we'll split it here. Let's take our instructions and actually store them somewhere. How do you use this? Can I do dot push? Is that a thing? So I could probably give it a capacity. Does it do the does it need the explicit number of bytes, or does it need the number of elements? Let's find out. It doesn't, it looks like we need to give it the explicit number of bytes. So does that work? We need the constant list now. Oops, am I stupid? Ensure. Or, well, I can do what you said before and just like, where do I do that? Do I do it like here? Oh, I see what you're saying. Yeah, then in that case, let's just, I don't care what it starts out as. So we'll just say ensure capacity. I think that's probably fine. Oh, just number of elements? So up here I can get rid of this times 32. I wasn't sure. I was reading the built-ins code in Jakt, And I'm not very good at reading C++, so, but I trust your word. I keep doing that. Let's local list is an array of locals. Scope start. Oh, why don't I just call it that? It kind of worries me that the compiler doing the error checking, the syntax error checking, has gone completely silent. Usually that means I've done something horribly wrong. You know, these probably need to be mutable, right? Because I'm pushing to them. What happens if we compile right now? I want to see why the compiler is expected set struct. Oh. Do I have to initialize them like this? Yeah, that looks right. Right, wrong number of arguments. Of course, we have this now. Instruction list does not take a usize. It takes U32. So we'll just do we'll get a little crazy and do a U32 cast. I should probably just add a function that just parses a U32, because these are just always, instructions are just always going to be a U32. Like, what are you going to do if it's a U64? We're talking about like a very specific bytecode structure, right, where instructions are designed around being 32 bits wide. So we may just not support having any size instruction other than 32 bits. So we parse the local list now and save it. And now we need the value list. So say just an array of strings. I think we didn't do an ensure capacity on a couple of these. Now we give it the code list or instruction list, the constant list, the proto list, the line info list, local list, and a value list. Okay. Can we build? This argument to member function ensure capacity has type const Jakt internal array string, but function is not marked const. Oh, maybe I have to make these mutable. Yeah, that's probably it, because it's a string array. Yeah, that was it. Okay. Okay, I think we're saving it. I think this is good. I think I'm gonna be done for the night. It's past 12. The time flew, and now it's almost 1 a.m. here. Let's write a commit, shall we? So what did we do? We we finished parsing all of the lists. So parsing out instructions, constants, or we'll just say like parsing out entire Lua chunks, whole Lua chunks. Something like that. I'm really bad at commit messages. Oh, and we're on GitHub now. github.com/apex/ that should be where the repository is at. So you can come see the code that I've written so far. Yep, looks like it's up there. So thanks for stopping by. I'm going to end the stream for tonight. Peace.